Welcome to our video on energy transitions, comparing solar, wind, and nuclear power. In today's discussion, we'll explore the key factors driving the shift towards sustainable energy solutions, examining both renewable and non-renewable sources. From assessing carbon emissions and their impact on climate change to understanding land use and energy storage, we'll dive deep into the nuances of solar, wind, and nuclear energy. Join us as we analyze cost dynamics, environmental implications, and job creation, shedding light on how the future of energy might look in a world increasingly focused on sustainability and efficiency. 1. Renewable versus non-renewable energy sources. In the realm of energy production, the distinction between renewable and non-renewable resources is crucial. Solar and wind power stand out as renewable sources, drawing energy from the sun and wind, respectively. These resources are abundant and naturally replenished, positioning them as pivotal players in sustainable energy strategies. On the other hand, nuclear power, while not emitting carbon during its operation, relies on uranium, a finite resource. This dependency places nuclear power in the non-renewable category. However, the conversation around nuclear energy is nuanced since it provides a low-carbon alternative to fossil fuels. Understanding these dynamics is essential as the world seeks to transition away from traditional energy sources. 2. Carbon emissions and climate change. As the world grapples with the impacts of climate change, reducing carbon emissions has become a global priority. Solar, wind, and nuclear power are vital in this transition due to their negligible carbon emissions during operation. This characteristic makes them attractive alternatives to fossil fuels, which are notorious for their high carbon output. By harnessing solar and wind energy, we capture the natural elements without releasing harmful gases into the atmosphere. Similarly, nuclear power offers a low-emission energy source, although its reliance on uranium raises sustainability questions. Together, these technologies provide a path toward a cleaner, greener future. 3. Land use considerations. The spatial requirements of energy installations are a significant factor in their implementation. Solar farms, particularly those on a large scale, demand substantial land areas to capture sufficient sunlight. This requirement can sometimes conflict with land availability for agriculture or other uses. Wind farms, however, offer more flexibility as they can be spread over land or placed offshore, minimizing their impact on land use. In contrast, nuclear power plants boast a smaller land footprint relative to the energy they produce, making them efficient in terms of space. Each energy source presents unique challenges and advantages regarding land utilization. 4. Energy storage and reliability. One of the primary challenges with solar and wind energy is their intermittency, as they depend on weather conditions. The sun doesn't always shine, and the wind doesn't always blow, necessitating energy storage solutions like batteries to ensure a steady energy supply. This intermittency can complicate grid management and requires innovative solutions to maintain reliability. Conversely, nuclear power provides a consistent and reliable energy output, unaffected by weather patterns. This reliability is a significant advantage, allowing nuclear plants to serve as a dependable energy source alongside renewables. 5. Cost dynamics. Installation and maintenance. The economic landscape of energy production has evolved dramatically over the past decade. Solar and wind energy have experienced significant cost reductions, enhancing their competitiveness in the energy market. Technological advancements and increased manufacturing efficiency have driven these cost declines. However, nuclear power faces high initial construction costs and lengthy development timelines, which can be prohibitive. Despite this, nuclear plants benefit from lower operational costs over time, making them a viable long-term investment. The financial aspects of each energy form must be carefully considered in planning energy transitions. 6. Energy density and efficiency. The energy density is a crucial factor in evaluating the efficiency of different power sources. Nuclear power boasts a much higher energy density compared to solar and wind, meaning it can produce more energy per unit of fuel or land area. This high energy density translates to less fuel consumption and smaller land requirements for the same energy output. Solar and wind power, while renewable, have lower energy densities, necessitating larger installations to generate equivalent power. The efficiency of each energy source plays a critical role in determining its suitability for various applications. 7. Lifespan of energy infrastructure. The longevity of energy infrastructure is another critical consideration in energy planning. Solar panels typically have a lifespan of 20-30 years, while wind turbines last about 20 years. These timelines necessitate periodic replacements and upgrades to maintain energy production. In contrast, nuclear reactors can operate for 40-60 years or more with proper maintenance and upgrades. This extended lifespan makes nuclear power an attractive option for long-term energy strategies, despite its higher initial costs. The durability of energy infrastructure impacts both economic viability and sustainability. 8. Environmental impact and wildlife. While solar and wind power have minimal environmental impact during operation, they are not without challenges. Wind turbines, for example, can affect bird populations and wildlife habitats. Careful planning and mitigation strategies are necessary to minimize these impacts. Conversely, nuclear power produces radioactive waste, which requires secure, long-term management to prevent environmental contamination. The environmental considerations of each energy source must be balanced against their benefits, ensuring that energy transitions prioritize ecological preservation. 9. Job creation in the energy sector. The transition to renewable energy sources has significant implications for job creation. The solar and wind sectors are notable for generating numerous jobs, particularly in manufacturing, installation, and maintenance. These industries have become vital employment drivers, supporting local economies and fostering innovation. The nuclear industry also offers high-paying, long-term jobs but on a smaller scale compared to renewables. The potential for job creation in the energy sector makes it a critical component of economic development strategies worldwide. 10. Global adoption and energy mix. Globally, solar and wind power are rapidly being adopted as countries strive to reduce carbon emissions and embrace sustainable energy practices. This trend is particularly pronounced in regions with abundant sunlight and wind resources. However, nuclear power remains a key component in some countries' energy mix, especially those seeking stable, large-scale energy production. Each nation's energy strategy reflects its unique resources, priorities, and challenges, highlighting the diverse approaches to achieving energy transitions. 11. Grid integration challenges. Integrating large amounts of solar and wind power into the energy grid presents technical challenges. The variable nature of these energy sources requires modernizing infrastructure to handle fluctuating energy inputs. Advanced grid management technologies and storage solutions are essential to accommodate these variations. In contrast, nuclear power integrates more easily into existing grids due to its constant output, providing a stable energy foundation. Addressing grid integration challenges is crucial for maximizing the potential of renewable energy sources. 12. Decommissioning energy infrastructure. The end-of-life phase of energy infrastructure involves decommissioning processes that vary by energy source. Decommissioning solar and wind installations requires recycling or disposing of materials like metals and glass, posing environmental considerations. Nuclear decommissioning, however, is more complex and costly due to the need for handling radioactive materials. Ensuring safe and efficient decommissioning practices is vital to minimizing environmental impacts and maintaining sustainability. 13. Public perception and support. Public perception plays a significant role in the adoption of different energy sources. Solar and wind energy generally enjoy high public support due to their environmental benefits and renewable nature. In contrast, nuclear power often faces opposition due to concerns over safety, waste management, and the potential for catastrophic accidents. Addressing these concerns through transparent communication and robust safety measures is essential to gaining public trust and advancing energy transitions effectively.